process. I don't know if any of you follow the Common Core news, but it's gotten political in the last year. And we're seeing some of the costs and opportunities of standards that mean to appeal to people based on what's between the covers instead of what people say about them. So there's a shot of the bibliography of this thing. Now, in terms of what they require, obviously, as math teachers, you will have read them carefully and gone bullet by bullet to absorb them. It's useful to also zoom out and say, at a high level, what are the shifts that we're looking for? And drawing on all the evidence that we drew from, both from countries, we get into some of it here today, college readiness and so on, 3 shifts: focus, coherence, and rigor. Focusing strongly where the standards focus is first and most important. It creates the conditions for the other two to happen. Coherence, the simple idea that math ought to make sense, that what students learn in each grade should build logically upon what they learned last year and prepare logically for what they're going to learn next year. And that at each given grade, they should be making the connections that make the mathematics make sense. And by rigor, by more rigor, I mean that we strive equally for 3 things: conceptual understanding of the mathematics, skill and fluency with the procedures, and ability to apply what we're learning. Everybody has their favorite one of these 3. And depending on which audience I'm talking to, there's probably a lot of fans of 1 or 2 or 3. Standards say, cut it out, kids need all 3 of them. We need to commit and work as hard as we can for all 3 of them in the each grade. Students need all 3 to make progress through mathematics 2 and through algebra, and to be successful mathematically in high school, after high school. So we'll walk through each of these shifts and talk about where they come from and what they mean. So focus, we're going to look at through 2 lenses. One, international comparisons. What do high-performing countries' standards look like? And then we'll look at it through the lens of college readiness and remediation issues. Looking at high-performing countries, they tend to study fewer topics in each grade, teach them in greater depth, and to a greater level of mastery so that students can build on a secure foundation year by year. There's an anecdote here from this 2005 study that Hong Kong, the country that scored the highest on the TIMSS in grade 4, only covered half the topics on the TIM through grade 4. That data point in this study was reinforced by a general trend. Ironically, the more topics a country covered from the TIMSS, the less well they did. And to math teachers, I think this finding is not as mysterious as it is to the content-neutral policy wonks out there. Because as math people, we know that there is a powerful core of the intricate, difficult, and necessary things, that once you can stand on that, you can reach out very far. So pictorially, people have seen this. This is the words here are actually not meant to be read. It's meant to be a picture that you can perceive by Gestalt, which is it's a topic grade matrix. Grades go across the top, the topics go across the bottom, and again, the topics are not listed, but they go from elementary to advanced. So elementary being whole numbers and place value and so on. Advanced being things like congruent symmetry functions. And the composite picture of high-performing countries is on the left, and it has a cascading triangular picture in which, although it's upside down, the advanced material is being built on a sturdy base of the elementary material. The composite picture on the right was, circa 2002, what 2/3 of the states in the sample were covering, and it's a very different shape. It's a picture that says, in any given grade, we study everything we can possibly study, and some things we can't. Now, state standards have been drifting toward a more focused picture, but they haven't necessarily been drifting toward a more coherent picture, in which the actual links from grade to grade are more logical and dependable. And in the absence of common standards, the textbooks haven't been able to follow anyway. When you look at other countries, they are focusing on fewer things with higher expectations. Again, concepts, skills, and applications. By higher expectations, I don't mean just one of those three things, I mean all three of those things. So here, for example, and I'll narrate it for you, the MCAS test has long been thought of as the Cadillac of state mathematics tests. They spend a lot of money per pupil to assess mathematics in Massachusetts, and so it was decided to compare that test to tests that Hong Kong students take. And here on the left, we have a Massachusetts problem. Maria is thinking of a number. The clues for her number are below. It's a multiple of 5, it's even, less than 18. Which of these could be Maria's number? As compared to a problem that was matched to that in terms of the content, which is this wonderful puzzle that involves the long division tableau. It is not simply a problem on long division, but involves a lot of number sense, a lot of arithmetic, a lot of high-level thinking. It is an amusing problem to solve yourselves. And so you can see that a lot of the arithmetic is taken for granted and then built upon and then assessed at this deep level. Other findings from that same study that are kind of interesting, they say, well, okay, so Hong Kong is doing much deeper, richer problems about arithmetic. Maybe we're doing better on things that we do, like patterns. So bottom left, here's a pattern problem. It's banana, orange, 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 banana, orange, 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 banana, orange, orange, orange. They said, let's see, maybe we're beating Hong Kong with the banana, orange type stuff. Well, couldn't find it. They're not doing it. Because the deeper, richer treatment of arithmetic doesn't come for free. You pay for it by not doing other things. Other examples of this here. They're not playing phony, one of the messages is they're not playing phony algebra games in early grades either. Instead, they're using the structure of arithmetic to train the mind for algebra. Many people were surprised to see that the Common Core Standards doesn't have a high-level algebra organizer in the early grades. That follows the model of many of these countries, in which arithmetic is an important life skill, as well as a rehearsal for algebra, which has implications on how it's taught. So as it's intimated, everybody's in favor of cutting the budget. Once you start talking about what you're going to cut, everybody gets mad at you. We had lots of feedback that said, love the focus of these standards. Now, if you could just add this one thing. So how is focus attained in early grades particularly? Bottom line on the bottom, concentration on arithmetic. And for a general audience, that's all I need to say. I'll emphasize again, that means the concepts of it, the skills and fluencies of it, and the application. There are also, since we're experts in the room, we know there are aspects of measurement that support arithmetic if they're taught in a way that supports arithmetic. So that's the trick we have to manage. So at a high level, how would I describe the focus in early grades? So grades K through 2, it's a master class in addition and subtraction. Multiplication doesn't actually enter the standards until grade 3. Now, in addition and subtraction, I include place value. And again, I include concepts, skills, and problems. In grades 3 through 5, other things are going on. The eye does, the lens, the spotlight does turn to multiplication and division of whole numbers and fractions. Again, concepts, skills, and problem solving. And there's very little data work in K5, very little. What little is there is tightly coordinated with the learning progressions in arithmetic. So, for example, in grade 2, there is a standard bar graphs and picture bar graphs. And they're not scaled. They have a scale of 1. One box equals one item. In grade 3, the uptick is that the bar graphs have scales. So one box equals 3, 5 items. It's not an accident that scaled bar graphs enter the same grade multiplication enters. We're meant to have a tight handshake here. Bar graphs are not their own fetish that we're going to spend ages and ages on.